Hi, Excel Geo. What I'm doing now is I'm going over problem number 25 in section 10.5, okay? 10.5 on page 677, number 25. I got a request to go over it, so I thought it would be best to make a video explanation of how this works. So now, on question 25, they said that you had to look at example 4, which was on page, where was it? On page 674. Now, this is the diagram. The circle here is Earth. All right, guys, the circle here is Earth. This dot up here is my hot air balloon. All right, it says you're flying a hot air balloon that is approximately 1.2 miles above the ground. Use the method from example 4 to find the measure of the arc that represents the part of Earth that you can see. The radius of Earth is about 4,000 miles. So here's the center of my circle, which is the center of Earth. Now, if you're up here in the hot air balloon, you pretty much can see everything from one tangent to the other, the two tangent segments. That's the arc in which you can see. And that's the arc we need to find the measurement of. Now, if this is my hot air balloon, and this is obviously not drawn to scale, I know that this segment here is 1.2 miles. And the radius of my circle here is 4,000 miles. All right, guys? Now, what we want to look at here, so I know the radius, but look at me. If this is a radius here, this here is also a radius. And we also know, because this is a tangent segment, if I draw a tangent segment, this here will be a right angle. And how did I draw this? I used the diagram from example 4, which says that if I have something above the Earth, all right, I can see basically if I draw the tangent from that item, object, the hot air balloon, to the circle, if I draw two tangent segments, that arc that remains there between the two tangent segments, the points of tangency, will be what I can visually see. Now, I know that if I draw a radius to a point of tangency, it makes a right angle. So right now, I have this here as a right triangle. Now, if I pull out that right triangle, so let's take a look at that right triangle. So I have this right triangle that we're talking about. I have my right triangle. Now, this leg here is 4,000 miles. Now, this angle here, see this angle? That's the same as this angle right here. This angle would be a central angle because this is the center of the Earth. Now, if I look at that, this hypotenuse would be a radius of 4,000 plus the 1.2 miles. So my hypotenuse would be 4,000, 1.2 miles. Now, if you take a look at that, what you have here is I want to find this angle. We're going to have to use our trigonometry. This is an adjacent, 4,000 miles, adjacent segment and a hypotenuse. So I can write that the cosine of this angle, I'm just going to label it angle theta, theta will equal 4,000 over 4,001.2. Now, guys, we have to remember we're going to use our graphing calculator here to help us out, all right? So if I look at this, I need to put this in my graphing calculator, and I'm going to write theta would then be the inverse cosine of that value. Now, remember, in the graphing calculator, we need to make sure that it is in degree mode. All right, guys. All right, I just ran and got my graphing calculator. Forgot it. So here's my graphing calculator. Go to mode and make sure that degree is highlighted. If it's not, go over to degree, press enter, and then quit out. Everything will be in degrees. And if I want to find theta, I'm going to do second cosine, which gives me the inverse, and that helps me find my angle. And I'm going to put 4,000 divided by 4,001.2. And I'm going to get that angle theta to be approximately 1.4 degrees. All right, guys? If you didn't get 1.4, again, check that your mode is in degree. We're in degrees, not radians. Make sure that mode is in degree. So that's my answer, 1.4. That's my answer for this central angle. This central angle here is 1.4. Therefore, the arc from here to here, that blue arc, If this is central angle is 1.4 degrees, that blue arc also measures 1.4 degrees. However, if we think about this, if I have two tangent segments that share a common external point, we know that those two segments are congruent. We also know that two radii are congruent, and we know the common segment that they share, that hypotenuse is congruent. So we know that these two triangles would be congruent by the SSS congruence postulate. So therefore, if this angle here is 1.4 degrees, the angle here on the opposite side, that corresponding angle in that congruent triangle, would also have to be 1.4 degrees. Meaning the entire arc that we would see would be 1.4 plus 1.4. So your entire arc would measure, that you can see, 2.8 degrees. You'd either take the 1.4 and double it, or just do 1.4 plus 1.4, same method, either way, and you would get your answer that the entire degree that you can see is 2.8 degrees. All right, I hope that helps. If it does not, please visit me during office hours, and I will go over it again. All right, bye guys.